In these next couple lessons, we'll look at some different constructions that we can do. So this particular lesson deals with partitioning a segment according to a given ratio. You're basically going to take a line, you're going to split it up into chunks so that this ratio is met. So here we have a segment given to us. We are supposed to construct point L on that segment so that the ratio of the length of AL to the length of LB is 2 to 1. So we want length of AL to be twice as large as the length of LB, and we're doing this with a construction as opposed to measuring it using a ruler. So the first step in this construction is to draw a ray. In this case, we're going to call it AC, that is not on that segment. So we're going to take our straight edge, and we're going to start at point A. You always want to start at one of the endpoints of the given segment. We're going to draw a ray, nice long ray that would be, in this case, above. Doesn't have to be above, but most of the time, most people draw it above. And then since we just gave it a name AC for this lesson so that we can talk about, you use that name in the directions, we'll label that point C as well. All right, now we have to determine the total number of sections that we need for this. Okay, this is done by adding the numbers in that ratio. So the given ratio was 2 to 1 up top. So we have to add those together to find that we're going to have 3 sections that we need to split our original segment into. Now we're going to take our compass and we're going to draw equidistant arcs on this ray that we have added to our picture. So equidistant means we're going to use the same setting each time, and we can pick whatever setting we want, and we have to make as many arcs as we have sections from step 2. So first start at the end point of the ray, make my first arc, move my compass to that intersection, make my next arc, one more time, move my compass to my new intersection, and make my last arc. So I've made 3 arcs because I have 3 sections that I need to split segment AB into. Now, step 4 says draw a segment from the last arc to the end point of AB. So this is just taking your straight edge and drawing a segment from that last arc to this other end point of your original segment. So now what we just did is we created an angle between ray AC and this last segment that we just drew here back to point B. So now step 5 says we have to construct congruent angles at each intersection of an arc and ray AC. And we're going to construct congruent angles congruent to this angle that we just formed in our last step. So that means congruent angle construction, something we hopefully know how to do pretty well right now. This is my original angle, so I need to put the point of my compass at the vertex of that angle, make an arc that goes through both sides of the angle, keep this setting, move the point of the compass to the next intersection of the arc and the ray, make this arc, and then do one more. On the last intersection. So now, still continuing with the congruent angles construction, I now need to take my compass, open it to the width of the arc in this original angle. See if this one's any better. Oh, so the computer only letting me use certain settings isn't going to make this very easy here. There, that one's. We'll have to go with that. So now we take that setting, move it to the intersection of one of the arcs and ray AC. Do the same thing down here. Okay, now finish out this construction by actually taking your straight edge and drawing from your original intersection to the intersection of the two arcs. So this is what it should end up looking like. Again, the computer is not letting me use an accurate enough setting. So we should have a construction that ends up looking like this. Notice those three lines that I have here. Okay, let me label this for you so you can see it a little easier. These three lines should end up being parallel. You'll know if you've done your construction correctly and accurately if those lines are actually parallel, which is what we want. They need to be parallel so that when we go through and find exactly where point L is going to be, we know that these sections that segment AB is split into are all congruent to each other. So now, going back to the original problem, if the length of AL to the length of LB is supposed to be the ratio of 2 to 1, that means I have to go to the point where I have two sections from A to L, and I have one section from L to B, and I put a point there, and I label it. Sorry. I label that point L in this case because the problem says we are using that specific point. All right, now I'd like you to try the second example on your notes. Either rewind this video or maybe open another tab on your computer and go to the YouTube playlist and watch the first section of this video again. Rewind it, fast forward it, whatever you have to do to remind you of the process that you need to be using. Try out number 2, and we'll take a look at what this should look like when we're back in class. The third example on our notes, we're going to do the same thing that we did with the construction, and now we're going to do it using actual coordinate geometry. So the first thing that we should do is take the points that we're given, points A and B, and actually sketch them on a graph. This doesn't mean that you actually have to measure anything or use graph paper. This is just a visual for us to help us out. So when I graph these, just kind of eyeballing where they would be. Notice I also have point P in here. So now we have a ratio of 3 to 2. So from A to P and then from P to B, we should think of this as AP would be 3 of those sections that we would have constructed. P to B would be 2 of those sections. So A to P would be slightly longer than P to B. So just like with the construction, we again have to find the number of sections. So to find the number of sections, all you have to do is you take the two parts of your ratio and add them together. That tells you how many sections you would have. Now we have to determine the fractional part that point P is away from point A. So that means we're going to take 3. So the numerator of this fraction will always be your first number in your ratio. And then we're going to put that over our 5, which is our total section. And you'll be able to do that every time you have a problem like this. It's going to be the same setup for this fraction. Okay, now we have to calculate slope of our original segment, and notice we're not going to reduce. We're not thinking this is slope necessarily. We're thinking this is how many moves up, how many moves down, left, right we would make to go from A to B. So slope is y2 minus y1. So if I take 10 minus 4 over x2 minus x1, so this would be 6 minus 3. I would end up with 6 over 3. Notice again, not reducing. I'm not going to say that this is 2. I'm going to leave it right here. So I'm going to calculate now fractional parts of the slope. I'm going to use the fraction from part B and the slope from part C to actually figure out how far up I would move and how far right I would move to go from A to P. So I'm going to take that fraction, 3/5, and if I'm dealing with the run, we have to remember slope is rise over run. So I need to take 3/5 of that 3, which if we were to multiply those together, we'd get 1.8. Then I would take 3/5 of the rise, which was 6, to get 3.6. So what those values are, those are actually the values of the moves that I would have to make to go from point A to point P. So if we're going to calculate or find our new coordinates of P, we're going to add that new run, the 1.8, onto the x coordinate, and then we're going to take the new rise and add that to the y coordinate of A. So point P, we're going to find by taking 3 plus 1.8, and then we're going to take 4 plus 3.6. Now I know we're adding those because if we look at our diagram up here, to go from A to P, we have to move up and right. So those need to result in larger values for the x and the y. So we would need to use addition for this. So now we're going to write this the correct way. Point P would have the coordinates 4.8, 7.6. So now again, I'm going to have you pause the video and just work on number 4. Again, either rewind this video or go to the YouTube playlist to go through again the example of how to do this. And then we will check this again when we're back in class.